Hey folks, Professor Gray here. Ready to talk to you a little bit more about two independent samples hypothesis tests. As mentioned earlier, there are three types of hypothesis tests that involve two samples of independent data. We've talked about two-sample proportion test and two-sample z-test. Let's talk about two-sample t-test. Here again is the notation for two means. Mu sub 1 is the population 1 mean, sigma sub 1 is the population 1 standard deviation, n sub 1 is the sample size of sample 1, x bar sub 1 is sample 1's mean, and s sub 1 is sample 1's standard deviation. Corresponding notation applies to population 2 and sample 2. They would have sub 2's instead of sub 1's. For a hypothesis test that involves two means where the population standard deviation is unknown, we use a two-sample t-test. This uses a t-distribution, thus the t, and the test statistic that's shown on this slide. For the most part, we won't use this formula. Instead, we'll use the calculator command toSamp t-test. Again, that's in the Stat and Test menu. Well, you may pool standard deviations in two situations if you're running a two-sample t-test. If the two sample standard deviations are sufficiently close, or if there's reason to believe that the population standard deviations are equal. Ordinarily, we will not pool, but these are two special circumstances in which the option is available. Let's do an example. An advertising executive claims that there is a difference in the mean household income for credit card holders of Visa Gold and MasterCard Gold. So a random survey of 100 customers from each group is performed, and the results are shown. Let's test the executive's claim at a 5% significance level. The first step in this hypothesis test is to identify the type of test. Because we're testing two means, and we do not know the population standard deviation, this will be a two-sample t-test. The next step is to identify the hypotheses and label the claim. The null hypothesis is that the means are equal. For the alternative hypothesis, I'll use the same symbols, but I'll change to an inequality between them. And we're testing the executive's claim. The executive claims there is a difference . So for the alternative hypotheses, I'll use not equal to for my inequality. This will be a two-tailed test. If two numbers are not the same, if they are different, then they're not equal. So that's the claim I'm testing. For the next step, I'll find the p-value. For that, I'll use the calculator. Under Stat, Test, and two-sample t-test, I'm going to input my data. If your data are in list, then you would highlight Data, press Enter, and then put that information in the calculator. Because this example has summary statistics, I'll highlight Stats and put that information in the calculator instead. Let's let the sub 1s be the Visa Golds, the sub 2s be the MasterCard Golds. On the next line, I'll match up my inequality for this two-tailed test, and I'm asked if I would like to pool. The sample standard deviations are pretty different, and I don't have a reason to believe that the population standard deviations are the same, so I will not pool and answer no. When I calculate, I get the t-score, test statistic, and right underneath I have the p-value, or the probability of this sample data occurring under the assumption that the null hypothesis is true. The next step is to compare that to the significance level. In this problem, we're using a 5% significance level. So alpha would be 0.05. You can put other zeros on the end of alpha if that helps you compare. So which is bigger, P or alpha? In this case, P is bigger, so we fail to reject the null hypothesis. In the last step, we'll interpret this outcome in terms of the original claim. Because we failed to reject the null, and the claim was the alternative, we say there's not enough evidence to support the claim that there's a difference in the mean household income for credit card holders of Visa Gold and of MasterCard Gold. That concludes this hypothesis test.